In this video, we're going to be talking about the properties of sound. So we already know that sound is a type of energy. It is not a transfer matter, but it travels in the form of longitudinal waves, and it's formed by the disturbance of a medium. Because it's formed by disturbance of a medium, it's not able to travel through a vacuum. Now, there are multiple parts when it comes to a wave. There's amplitude, wavelength, and frequency. Amplitude is the distance between the line of propagation and the line of propagation to the crest, and the line of propagation to the trough. Wavelength is the difference between crest to crest or trough to trough. And frequency is the number of waves that happens per given cycle. So let's say, for example, if there were 2 waves happening per cycle, then the frequency would be 2 hertz. Now, the thing about frequency is, since it's a speed of vibrations, or the number of vibrations that's happening throughout a certain speed that we're giving it, we refer this as the pitch. And amplitude that we have over here, because it's showing the amount of energy that's happening in the wave, it's showing that compression and rarefaction, which is the amount of particles which causes a higher amount of vibrations leading to more energy. We call that volume, or another word, intensity. Just like in height, we measure in feet, inches, or meters, and in weight, we measure in pounds or grams. In sound, we measure through decibels, or it would be dB. Decibels, the normal sound like when I'm talking, it would be around 60 decibels. But if I were to be whispering, it would be 30 decibels. So now the thing with humans is that they're not able to go beyond, they're not able to hear beyond 10 or 15 decibels. So there are few animals that are able to hear some very soft sounds that we're not able to hear at all. That's called ultrasound. Also, there are very high notes that we cannot hear because our ears are not able to interpret it, but there are high notes all around us that we're not able to hear, but some animals are able to hear, like dogs. So now, we're going to be moving on to a few demonstrations over here. We're going to be testing the intensity, and we're going to be testing the pitch with these 4 cups. Notice that 1 cup is filled with water, 1 is halfway through, 1 is 1/3 of the way through, and 1 has no water at all. So now I'm going to be using this spoon and tapping against each of these glasses to see the kind of sound that they're going to produce. So I'm going to start now. So we're going to start off with the one with the most amount of water. So yeah, hear that. Second one, third one, fourth one. If we were to figure out the intensity and the pitch, we would obviously say that the first one would have the most amount of intensity because of how much energy is being produced. The thing is that because there's water in each of these cups, the medium difference slows the particle vibration. And because of this medium difference, it's not able to generate a higher intensity. However, since this glass over here, it's all in the same medium, it's just air. Since it's all in the same medium, it keeps that same intensity. Hence, it creates a higher volume or a higher intensity. So now let's move on to finding out which one has the higher pitch, or in other words, which one generates a higher frequency. So I'm going to be testing it again, and we're going to be looking for how loud it is. Alright, so after looking at this, we can obviously tell that the cup filled with water has the most amount of frequency. This is because because it's mainly water, and the thing about air is that since there's less particles within the air, the vibration is not able to happen from one place to the other. Hence, it's reacting slower. But since water has more particles inside of it, the vibration is able to continue on, keeping that momentum, and hence it's able to generate a higher vibration or more vibrations, hence leading to a higher pitch. So if we were to look at it, the one with the most amount of volume or the most amount of intensity would be the one in air, but the one with the higher pitch would be the one in water. Alright, so now we're going to be moving on to this demonstration over here. Here, you can notice that we have a thin rubber band and a thick rubber band. We're also going to be testing based on volume or intensity and pitch. So I'm going to be pulling these both times. As you can see, if I were to look at these 2 rubber bands, we can tell that the second one, this thin one over here, seems to have a higher pitch. That's because it's creating more vibrations if we look at it compared to this one. So, however, the thing about the thick rubber band is creating a higher volume, and that's because since it's much more denser, it's able to create there are more particles which are able to release a larger amount of energy, hence it's able to keep for a longer time. So if I were to do it at the same time, this was able to keep longer because there are more particles leading to a higher energy. So it has so this one has a higher volume, but this one has a higher pitch since it's making more vibrations, having a higher frequency. Alright, so this is all about the properties of sound. So in conclusion, we can tell that amplitude has a higher amount of energy, which leads to the volume or the intensity of the sound wave, while frequency has, based on the number of vibrations or within a certain time, it gives the pitch, which is determined based on the speed of the vibrations. Now, amplitude and frequency and volume and pitch are not inversely related. It all depends on the amount of energy and the particle vibrations that the wave is producing.